Personal protective equipment, or PPE, is the clothing and equipment that forms the last line of defense between you and harmful materials in the laboratory environment. It's essential that you know what you should be wearing, when you should be wearing it, and how it should be stored, cleaned, maintained, and disposed of. Laboratory coats are designed to prevent street clothing from becoming splashed or contaminated by biological and chemical materials. There are various types, including V-neck front fastening, high-neck side fastening coats, which have an overlap at the front to provide extra splash protection, back fastening gowns, and disposable laboratory coats. These are useful for visitors to the lab. Which type of laboratory coat to wear will depend on the level of protection required and the kind of work that's being carried out, but all must fit correctly, not too small or too big, have full-length sleeves, preferably with fitted cuffs, and ideally the gloves should be pulled over the cuffs of the sleeves. Not have the sleeves rolled up, as this would expose the arms to potential contamination. Be fastened when in the laboratory, and only be worn in designated areas, for example, not in the general office environment. If you realize that a laboratory coat has been contaminated, it should be removed immediately and decontaminated before it is worn again. Laboratory coats must be stored, cleaned and disposed of appropriately. When not in use, laboratory coats should be hung on a peg, either in a lobby for donning prior to entry into a laboratory, or on a peg within the laboratory. If they are kept in the laboratory, they should be stored separately from normal clothes and close to the entrance. People should not have to walk through the lab and run the risk of bumping into others that are working there or brushing up against lab equipment in order to get to their lab coat. To reduce the risk of cross-contamination, laboratory coats should not be hung up on top of other laboratory coats or placed in contact with normal street clothes or personal items. Ideally, reusable laboratory coats should be autoclaved and laundered on-site at regular intervals or when visibly contaminated. Where these facilities are not available, laboratory coats should be soaked in an appropriate disinfectant for the time recommended by the manufacturer of the disinfectant, wrung out and then rinsed in clean water, possibly a couple of times, to remove the disinfectant. If deemed necessary, laboratory coats can then be sent off for laundering if there is a washing machine close by. Laboratory coats should not be taken home to be laundered. If a laboratory coat is going to be disposed of, it should be first autoclaved or disinfected. Suitable, well-fitting, closed-toe footwear is required in the laboratory to minimize the likelihood of slips and trips, prevent injury from falling objects, and to prevent exposure to hazardous materials. Shoes which leave the foot exposed should not be worn. Some laboratories may require the use of dedicated footwear, such as boots or clog-style shoes. Many laboratory tasks require equipment and samples to be handled, making hands the most likely area to be contaminated. While some procedures may not require gloves, they are essential for handling hazardous materials. It's important to note that gloves are only effective if they are selected and used correctly. There are many different types of gloves, and it's important that the type used is most appropriate for the task. For example, gloves that protect against biological agents may not necessarily protect against chemicals such as disinfectants. You need to have a clear understanding of the work you're about to do and the likely concentrations and volumes of hazardous materials you'll be dealing with, so that you can make an informed choice based on a risk assessment. Glove manufacturers' datasheets and websites provide detailed information on the level of protection their various gloves offer. The glove packaging will usually carry some useful key indicators that should be examined before use. The expiration date is normally shown alongside an egg timer symbol. Glove material may degrade over time, so they should not be used past their expiration date. Gloves that protect against biological agents should have a biohazard symbol on the box. This means the glove offers protection against bacteria and fungi. If the word virus is shown below the symbol, that means the gloves have been tested and shown to offer protection against viruses. Chemical protection is depicted by a conical flask of liquid within a shield. It's important to note that this does not mean that the glove will protect the wearer against all chemicals. The types and concentrations of the chemicals that the gloves do protect against are represented by letters below the shield. You should identify these chemicals before using the glove. A lowercase letter I inside the shield means that reference to manufacturer's instructions is required. The most commonly used glove material in the laboratory is nitrile. A number of other materials are used, including latex. It's important to note that latex protein can cause allergy over time. Powder-free, low-latex protein options are available, which can minimize the onset of allergy. Not every glove in a batch will be perfect. A small number will have been damaged or not correctly formed during the manufacturing process. A sample of gloves from each batch is tested by the manufacturer to calculate an acceptance quality level, or AQL, for that batch. In this example, the glove packaging shows an AQL of 1.5. This means that 1.5% of the gloves in this box may be imperfect, so it's essential to check each glove before use. To ensure a glove is safe to don, look for any imperfections, such as discoloration or obvious holes or tears in the glove material. There may be holes in the glove that are not easily visible. A simple way to check is to slightly inflate the glove. It's important not to breathe air into the glove, as the moisture in the breath will make the glove difficult to put on. Instead, flap the glove a few times to capture room air, and then gently push the captured air down the glove to inflate the palm and finger areas. If the glove remains inflated, it is safe to put on. If it deflates, it must be disposed of. When donning a pair of gloves, it's important that the material is not overstretched, as this can cause them to tear and increases the likelihood of holes appearing in the material. People have different sized hands, and even an individual's hands can change in size over time. For example, if the wearer gains or loses weight, or where ambient temperature changes occur throughout the year. It's important that the correct sizes of gloves are used. If gloves are too tight, this will cause them to overstretch and increase the likelihood of material failure. Conversely, if they are too big, then they may fall off the wearer's hands, or the excess material will crease and may get caught on equipment, increasing the likelihood of tearing or contamination. It's therefore important to have a range of glove sizes available for laboratory workers to wear. disposable gloves must not be reused. This symbol on the box means do not use a second time. They should not be disinfected, for example with ethanol, as exposure to disinfectants will reduce the integrity of the glove material. If at any time gloves become visibly contaminated, they should be removed immediately and disposed of to prevent cross-contamination of other PPE, laboratory equipment and samples. If at any time gloves show any loss of integrity, for example permeating chemicals, holes, abrasions or tears, they must be removed immediately and disposed of. If gloves become contaminated and are not removed correctly, the hands and wrists of the wearer can become exposed to hazardous materials. We will use a fluorescent marker in the form of a gel to show correct removal of disposable gloves. Firstly, we'll remove the gloves without using any specific technique. The wearer suffers significant contamination of their fingers. The correct method is: pinch the thumb and forefinger together on one hand. With the other hand, pinch the material near but not at the edge of the cuff and pull the glove down towards the closed thumb and forefinger, turning the glove inside out as you go. Stop on reaching the thumb and forefinger, so that the glove is only partially removed. Repeat on the other hand. Pinch the thumb and forefinger together. Then with the other hand, pinch near the cuff and draw the glove down. At this point, the gloves are both partially removed, with the clean undersides of the gloves now forming the outer surface. The gloves can now be removed by touching only the clean underside of the material. The wearer's hands show no sign of contamination. To remove reusable gloves correctly, gently pull the material at the fingers and thumb on both hands to start to pull off the gloves. Then place your hands together, palms facing each other, and walk the fingers through the glove towards the cuffs. After removing gloves, you should wash your hands, and we'll look at hand washing technique later. Reusable gloves can only be reused for a set period of time, especially when they are designed to protect against chemicals. They must be cleaned prior to storage to remove any chemical contamination and prevent prolonged action of the chemical on the glove material, which could lead to breakthrough. Cleaning reusable gloves must be carried out according to manufacturer's instructions. Glove materials can be degraded by ultraviolet radiation, so they must be stored in a dry place away from direct sunlight. Gloves should be autoclaved prior to disposal. Eye protection is designed to protect the wearer from anything that might impact on the eye, such as particles and splashes. It may also protect against ultraviolet radiation. There are a number of different types of eye protection, including safety glasses, safety goggles, and face shields or visors. Here, a dummy head is being sprayed with a dye, which fluoresces orange when dry. This visor gives good protection for the whole face. Safety glasses give good protection to the area around the eyes. These are prescription spectacles. They do not give good enough protection around the eyes, especially at the side. Spectacles are not designed to protect the eye, and they should not be used in place of proper eye protection. If someone needs to wear prescription lenses, then they should either wear safety glasses with prescription lenses built in, or wear goggles or a visor that can fit over their spectacles. eye protection should be worn where there is any likelihood of splashing. To avoid contamination of the eye protection, it should be put on with clean hands, for example, not after handling microorganisms. Eye protection must fit correctly and be comfortable to wear. If it's too tight or too loose on the face, then the wearer will have to keep adjusting it. If their gloves are contaminated, then they run the risk of contamination being transferred to their eye protection or their face. Where eye protection becomes visibly contaminated during use, it should be removed and decontaminated. Remember, it should be removed with clean hands to avoid contamination of the head. It should be cleaned and decontaminated following manufacturer's instructions before it's used again. Eye protection is normally reusable. It must be cleaned according to manufacturer's instructions prior to storage to remove any potential contamination. UV radiation can cause degradation to lenses and strap materials, so eye protection must be stored in a clean, dry place away from direct sunlight. Eye protection should be decontaminated prior to disposal. No matter how well PPE is used and removed, there is always the potential for hands to become contaminated with hazardous materials. It's of utmost importance that hand hygiene, preferably hand washing, is carried out before leaving the laboratory area. To start, soap or cleanser should be applied to one hand, and the other hand should be used to turn on the tap. Where possible, elbow or foot-operated taps should be used to avoid recontaminating hands during the washing process. After wetting the hands, they should be rubbed together to form a lather. All areas of the hands and wrists should be rubbed and covered with soap. Commonly missed areas include the back of the thumb, between the fingers, the fingernails and creases in the palm of the hand, and the wrists. So you should pay special attention to these areas. Hands should then be rinsed, preferably with warm water, until all soap is removed, before they are dried completely. It's important to note that soap can be an irritant to skin, so thorough rinsing and drying is essential to protect against irritation and dermatitis. Ideally, jewellery should not be worn in the laboratory, but if rings are worn, it is particularly important to rinse and dry the skin carefully in that area. Using hand cream or moisturiser after hand washing can also reduce the likelihood of skin irritation. In summary, personal protective equipment provides the final barrier between you and harmful materials in the laboratory. All types of PPE should be selected carefully for correct fit and effectiveness against the identified hazards. Checked for integrity before use. Fit correctly and be worn correctly. Removed correctly to prevent cross-contamination. Stored and maintained properly following manufacturer's instructions. Removed immediately if it becomes contaminated. And decontaminated before being used again or being disposed of appropriately.